calculations for moles and molarity. And it's also a little bit making up solutions, because that is the bread and butter of a bioscientist. And if you can't do that, you will be fired from a job quicker than you can say molarity. And to get started with, just give you an example. Let's say we have a molecular substance has a molecular mass. Molecular mass is, say, 98 gram per mole. So in other words, if you've got 1 mole of this substance, whatever this substance is, it will weigh 98 gram. And I want to know how many gram are in 2.3 millimole. Okay? So that's basically a typical question. And what I want you to do is think about how you would get this done. Let's do it together. What's the first thing that we are looking for? First thing that we are looking for is, what is the unit that we are looking for? Grams? Yeah? Are you happy with that? Yes. How many grams? It's basically, it gives it away. So, grams goes here. Long line. Do we have grams somewhere? Yeah? So we have grams in up here. We have grams up here, and the grams are already in the right position. They are on top. So all we need to write is 98 gram, and the mole is down here. Okay? So far, so good? Now, we want the grams, but we don't want the mole, so we have to find something with a mole, with a unit of mole, that we can place up here, so that the moles cancel out. Do we have anything with a mole? Yes, we have 2.3, but it's millimolar. Right? Ouch. Careful. We know that milli means 10 to the minus 3. So this would be 2.3 times 10 to the minus 3 mole. Yeah? And mole, the units cancel out. And what we've got left is 98 gram times 2.3 times 10 to the minus 3. And that is what we just simply plug into our calculator. Can anyone do the honors? 0.225. Is that right? 0.225 grams. And of course we have to have the same unit here, gram and gram. 100, yep, is about right. Did you get that? Yeah? Give yourself a pat on the back? Or whack your neighbor? Or whatever. No! Wrong! Let's do it together. So, what is the unit we are looking for? Mole, exactly. How many mole? Usually you can tell because what we are looking for is usually directly after the word many. Just for, the very quick ones. So we are looking for mole. Do we have mole somewhere? Where? We have mole. Of course, we have mole up here. So gram per mole. But the problem is we have mole below the line here, below this line. Well, doesn't matter, because what we do is we just write it in such a way that this mole is on top and the rest, this part here, goes underneath. So we've got 180 grams. And we've got mole up here. That's exactly what we want. But the grams are a little bit annoying, so we need to get rid of them. How do we do that? We place something else with grams up here so that the gram unit cancels out. Do we have anything with grams? Yes? Namely? 2.5 grams. So we put that down. 2.5 gram. And you see what happens? Gram and gram cancels out. And what we've got left is 2.5 mole divided by 180. Can somebody do the honors? 0.01314. So we round it to 0.014 mole. Yeah? And of course, we could convert that into millimole by just shifting the dot 3 times. 1, 2, 3. So it would be 14 millimoles. Okay? Happy with that? Make sense? Wonderful. Right. Now let's get another one. I have a molecular mass of 256 gram per mole. And I want to make a solution. I want to have 10 milliliter of 1 molar solution. How many grams do I need to weigh in? That's a little bit more challenging. Let's see if we can do that. Let's do it together, okay? So, what are we looking for? What is the procedure that we are actually doing? It's always good to have a sort of a little picture in your head. We have a container, and we put in some substance. That's our substance. And then we add water, usually water. So that it is a total of 10 milliliter. And the concentration of the substance, is 1 mole per liter. Because that is 1 molar. Yeah? Remember, if I write it as a capital M, it means mole per liter. Okay? So how are we going to deal with that? First of all, what is the unit that I'm looking for? Grams, exactly. How do you know? Because many. Yeah? So grams. Do we have anything where the unit grams is apparent? Loud? 256. 256 gram per mole. Yeah? Yee-hoo! We have grams in the right position. It's on top of the line. Now we have to get rid of the mole. Do we have anything where we've got a mole in it? Loud? Who said it? 1 molar, exactly, because that means 1 mole per liter. So let's put that in. 1 mole per liter. You see what happens? Mole and mole cancels out. Unfortunately, we have now a liter down there. Can we get rid of the liter? Yes. How? We could convert that into milliliter, or we could convert 10 milliliter milli into liter. So we could say 10 milliliter, that is exactly 10 times 10 to the minus 3. This is the milliliter. Yeah? So we could write here 10 times 10 to the minus 3 liter. And what you see is the liter cancels out. And all that's left, at the bottom we don't have any units left. We have 256 gram times 10 times 10 to the minus 3. Can anyone do it? Sorry, is 2.56 gram. This is a question. If you give that 100 final year students, 50 get it wrong. Right? For a simple reason, because I haven't told them that. Okay, here's another one for you guys. We have a molecular mass of 65,000 gram per mole. And I want to make up 125 milliliter of a 10 millimolar solution. How many grams do I need? Right, what are we looking for? What's the unit? Grams. Many grams. So we have grams. Grams anywhere? 65,000. Gram is luckily on top. So we have to write the mole down here. Gram per mole. Do we have any moles anywhere? Yes, we do. We have the moles in here because we know that we can write this as 10 times, now the milli, 10 to the minus 3, mole per liter. So we can write that here, 10 times 10 to the minus 3 mole per liter. Mole and mole cancel out. We've got left a liter. Do we have any liters? Any liters? Yes, where? We have 125 milliliters. So we've got 125 times 10 to the minus 3 liter. Okay? Liter cancel out. And all we have left is 65,000 gram times 10 to the minus 3 times 125 times 10 to the minus 3 and no further units. Okay? Happy with that? What do you get? So we get 81.25. 81.25 gram. Yes, thank you. Easy peasy. Right? Here's another one for you. Have a substance with 25 kilodalton. And I want to know how many mole are in 5 milliliter of a 40 millimolar solution. What's kilodalton? What's kilodalton? Okay, the way you interpret that, a dalton is just simply another posh chemical word for mass. Yeah? And kilo means 1,000. So you need to know that 1 Dalton is equivalent to 1 gram per mole. But because bioscientists and chemists, especially bioscientists, they try to obscure and obfuscate things, they love that. They want to make things complicated. That's why they introduced the Dalton. But with this definition, 1 gram per mole, you can easily figure out 25 kilodalton. That would be equivalent to 25,000 gram per mole. Yeah? That's all there is. So please remember Dalton and gram per mole, that's the same thing. So do you want to figure out what you have to do? Yeah? Okay, good. Okay, what are we looking for? What's the unit we are looking for? Mole. Excellent. Do we have anything with moles in it? Yes. What? 25,000. Good. 25,000. Mole, unfortunately, is down here, is below the line, so we have to write it the other way around. Yeah? So we write mole, and what do I write below the line? 25,000, what? 25,000 gram. Wonderful. Okay, now we need to get rid of the gram. Do we have anything with gram in it? One person said yes, another person said no. We could put in 1 gram over mole, 1 gram over mole. Yeah, as we have up there. And the gram cancels out, but the mole cancels out as well. No good. Actually, it's bum. What do you mean by it? Did you predict that it's bum? Good man. We can't do it with this approach. But you are rejoicing too early. Do we have anything else with a mole in it? Yes. What? Where? How? 40 millimolar. So here, this would be 40 times, and I get rid of this one here, 40 times 10 to the minus 3 mole per liter. This is 40 millimolar. Okay? Now I've got my mole again. I need to get rid of the liter. Do we have anything with a liter in it? It is 5 times 10 to the minus 3 liter. 5 times 10 to the minus 3 liter. Liter cancels out. And all I have left is 5 times 40 gives 200, thank you. And 10 to the minus 3 times 10 to the minus 3 gives 10 to the minus 6, exactly. You just add these together. Yeah? And I know that 10 to the minus 6, what unit is that? Loud? Micro. And of course, I forgot to write down my unit. So we've got mole. So this would be 200 micromole. Yeah? Simple. So basically, I played a trick on you. I gave you overkill of information. I gave you far more information than you needed with this 25,000. But that's life. Okay? One last thing that I want to introduce in this session to you. I have a substance with 175. Where? Wow, that's cool. 175 Dalton. I have 10 milliliter of this solution. And the concentration of this solution is 5% weight per volume. How many mole are in this solution? Oh dear, there's something new. It's this percent. And we need to sort of unpick what does this percent actually mean. Well, we know what percent mean. What does percent mean? Per 100, exactly. So here, this expression actually means 1 gram per 100 milliliter. This is what 1% means. And that's always the case. Percent weight per volume, means 1 gram per 100 milliliter. So a 5% solution is, so here we have how many? 5 gram per 100 milliliter. 10% solution, 10 gram per 100 milliliter. 100% solution, 100 gram per milliliter. Yeah? Okay, so how many mole are in this solution? What are we looking for? What's the unit? Mole? Do we have anything with mole in it, implicitly or not? Yes? Where? Doc? The Dalton, exactly. 175 Dalton. And we said a Dalton is nothing else but 175 gram per mole. Yeah? So Dalton, gram per mole. Percent, gram per 100 milliliter. So, but we have the mole in the wrong position. It's below the line, so we have to turn it upside down, as my friend from Scotland would say. No, I can't do that. So we have mole, and we have 175 gram. Now we've got the mole, we need to get rid of the gram. Can we do that? Yes, we have the 5 grams here. So let's write it down. 5 gram per 100 times 10 to the minus 3 liter. Of course, you recognize this is the milli. Okay, we got rid of the grams. Yoo-hoo! But we've got the liter left. Do we have liters anywhere? Where? 10 milliliters. So we have 10 times 10 to the minus 3 liter. And you see the liters cancel out. Hasta la vista. Even the 10 to the minus 3 cancels out, which is quite convenient. And all we have left is 5 times 10 grams. Oh, sorry, the grams cancelled out. 5 times 10 mole divided by 175 times 100. Can anyone do the calculation quickly? That's 50, 0. 0.02, 0.00. 0.00257. Yeah? 0.0026, and the unit is, of course, mole. 29. Is he lying? Yeah, something like that. So, what you should have learned today is that you don't need any complicated equations to remember. With this dimensional analysis, you can basically tackle whatever problem comes up just by looking at the units. What I want you, bless you, what I want you to also remember is definition of Dalton, gram per mole, and percentage. So 1%, 1 gram per 100 milliliters. Have a look at the exercises